What's up, pre-calculus students? Mr. Messner, AP Calculus teacher, pre-calculus teacher. I'm going to be doing the homework videos for you guys, and we'll get started with our first homework on logarithms. So you were introduced with logarithms last year in Algebra 2, but not sure how well you guys learned it, so that's why we're kind of reviewing the basics before we get into more complicated use of logarithms to solve more complicated equations. There's different ways to introduce logarithms and teach them. I kind of go with the way that helps us when we start solving, which is that logarithms are inverses. So if you have like an equation like this, and you want to solve for x, first of all, you can't divide by 3. Like 3 is not being multiplied by x, 3 to the power of x. So first of all, if you try to do this, that's not going to get you the right answer. Instead, we use the inverse function. Now you can think about this as being like almost like sine x equals, I don't know, a half. It's not that we divide by sine, right? We would take the sine inverse of both sides. Okay, and then you use your calculator, use your unit circle knowledge to figure out what the answers are for x. But for this, we would kind of do like, 3 inverse, but we don't use 3 inverses. It's confusing. Instead of like the inverse of like 3 to a power, we use a logarithm. And we say that log base 3 is the inverse of 3 to a power. Like sine inverse is the inverse of sine. This number needs to be the same as this number, okay? And you would do the same thing on the other side. You do the log base 3 on the left side of 9. Log base 3 of 3 to the x simplifies to just be x. It just undoes what 3 does as a base to the power of x. And you get x equals log base 3 of 9. Okay, and I kind of keep it like that. Now, conversely, if and the first set of 12 questions are, you're given a log 3 of 9 is 2, and we knew that. Here, the answer for x is 2. Well, this is kind of showing us that log base 3 of 9 is 2. And we'll show you how to type this into your calculator, or how you can kind of rewrite to just see that it's true, like 3 to what power is 9. Here, like log base 3 on both sides. So 3 to the x equals 9, x has to be 2, well, x equals log base 3 of 9. Log base 3 of 9 has to be 2. And we'll see how we can get that in a calculator or something. Now, going the other way around, it's like if you have a logarithm, or if you have an inverse function, like say if you have sine inverse of 1/2 is x, you would take the sine of both sides, right? Kind of undo that, and you get 1/2 equals sine x, so kind of back to where you started. We are going to do the same thing here. We are going to kind of go backwards to undo this logarithm. Now you look at the base of the logarithm, which is like the base of the exponent. That's telling you that we're talking about 3 to a power. And what I do is I take 3 to the power of both sides. I use this little caret to denote that I'm not multiplying. Instead, I'm taking 3 to the power. So it's like, here's like this power. Here is this like kind of power. 3 to the x, 3 to the log base 3 of 9. And I would do it to both sides. And this is how we undo the other way around. So 3 to the log base 3 of 9 is just 9. And we'd say 9 equals 3 squared. So that's what we're going to do here for all of these. We're going to examine the base, and we're going to take that base number to the power of both sides. So 3 to the power, 3 to the power, 3 to the log base 3 undoes each other, leaving you with just 9. 9 equals 3 squared, which is the one I just showed you. Go away. 9 equals 3 squared. Here the base is 4, so I take 4 to the power. Well, log base 4 of 4 is like 4 to what power is 4? 1. Okay, so to show that log base 4 of 4, 4 to the power, a 4 to the log base 4 undoes each other, leaves you just this 4. 4 equals 4 to the first power. 6 to what power is 1? Well, that's 0. Another way to see that, using the exponent form, take 6 to the power of both sides. Why am I taking 6? Because 6 is the base of the logarithm. 6 to the log base 6 will undo each other, leaving you with just 1. 1 equals 6 to the 0. 7 cubed is 343. Another way to show that, if you take 7 to the power of both sides, 7 to the log base 7 undoes each other, leaves you with 343 equals 7 cubed. Okay, so this would be the exponent way to show the same statement, log base 7 of 343 is 3. There's a 3, 3 to the power, 3 to the power, 9 equals 3 squared. Same question as we saw here. Here's a base 3, 3 to the power, 3 to the power, 3 to the log base 3 undoes each other, leaves you with a 1/3. 1/3 equals 3 to the negative first. You know this, 3 to a negative first power is the same as 1 over 3 to the first power. So 1/3 is 3 to the negative first. This is all correct. 4 squared is 16. The way to rewrite this in exponential form, the way I do it, take 4 to the power of both sides, because this is the base of 4. 4 to the log 4 undoes each other, leaves you with 16. 16 equals 4 squared. Base is 9 in this logarithm. Take 9 to the power of both sides. 1 over 81 equals 9 to the negative second. Okay, we talked about in the notes, if you just see log, it is assumed that it is a base 10. So log with no numbers underneath it, you're assuming that there is a 10 there. It's not a 1, it's a 10. It's a little bit different than what you might think. This is a common power used, 10 to a power, which is why log is used as a shortcut for a 10 to the power situation. So I would take 10 to the power of both sides to get 1 over 1,000 on the left side. These would cancel, leaving this equals 10 to the negative third. A couple more pretty easy ones. 32 to the 32 to the 32 to the log base 32 leaves you with a 4. 4 equals 32 to the 2/5. A way to kind of check that, the 5th root, you can rewrite this as 32 to the 1/5 squared, and then 2 to the 5th power is 32. 2, 4, 8, 16, 32. So 2 to the 5th power is 32, and then 2 squared is 4. So 32 to the 2/5 is 4. This is true. Base is 16. 16 to the 8 equals 16 to the 3/4. This is something you need to do when you get to calculus, is be able to evaluate 16 to the 3/4 without a calculator and figure out that it is 8. The way I would do that is to rewrite this as 16 to the 1/4 cubed. You know that like a power to a power, you multiply the powers, like 2 squared cubed is the same as 2 to the 6th. So 2 to the 16 to the 1/4 is the 4th root of 16. That also is 2, and then 2 cubed is 8. Base is 64. 64 to the, I get 8 equals 64 to the 1/2 power. A 1/2 power is the same as the square root. And these fractional powers are the same as roots, like the 4th power is a 4th root, a 1/3 power is a 3rd root, cube root. All right, now we're going the other way. So again, we focus on the base of the exponent. So the 6, this 12, this 16, this 5, this 125, and once my cursor comes back, we will do what I kind of showed you at the beginning, which is we will take the log base of the base number in the exponent. So here I would take the log base 6, log base 6. My cursor is being a little bit finicky right now. I'm not sure why. It should come back. I might have to like close this off and bring it back. Give me a second. Let me turn this off. Turn it back on. I'm using a wireless mouse here. Sometimes it does it, but usually not. All right. Hopefully. Yeah, it's acting weird. I'm going to just do the best that I can here. So if the cursor's jumping around on you, I'm sorry. I'm trying to close this off and open it back up. All right, so I would take the log base 6 of both sides. This is tough to see, but I'm writing over here on the right side, log base 6 of 36. Log base 6 of 6 to the power, that will undo the 6 to the power and just leaves the 2. Okay, so I focus on this base of the exponent. That's 6. I do log base 6. So this gives you 2 equals the log base 6 of 36. And this would be the logarithmic form of writing 6 to the second power is 36. Here, the base number is 12. So I would take the log base 12 of both sides. Log base 12. I'm writing on the right side. I don't have much space, but I'm writing on the right side. Log base 12 of 1. It's not multiplying. It's just like taking the log of, similar to how you like take the sign of something. You don't multiply by sign. Log base 12 of 12 to the 0 is just 0. The log base 12 of 12 will cancel. Just leave the exponent 0. And that equals the log base 12 of 1. The base of the exponent is 16, so I take the log base 16 of both sides. So the logarithmic form of 16 to the negative first power equals 1 over 16 is negative 1 equals log base 16 of 1/16. Okay, so this is the logarithmic form. There are other ways to kind of teach rewriting this. Some people kind of move this 2 and move this 36 and kind of do like a circular pattern, and then you end up with the same statement, just flip-flop. So a lot of teachers will keep the log on this side. I don't think it's necessary or necessarily helpful to do this, write it this way. This way and this way are the same. Obviously, like if A equals B, you can write B equals A. The base is 5, so I'm going to take the log base 5 of both sides. Let me just write it so you can see. I'm doing log base 5 of 5 to the negative second, so it's like next to it. I'm taking the log of both sides, like to the left of it, not adding an exponent, not multiplying, just taking the log base 5 of both sides. Gives you negative 2 equals log base 5 of 1 over 25. 125 is the exponent here, so I'm going to take the log base 125 of both sides. Again, this is not below it. What I'm writing is log 125 of 125 to the 2/3 equals log of 125 of 25. This log base 125 of 125 to the 2/3 is just 2/3. So 2/3 equals log base 125. This is the logarithmic form of the same statement. Taking the log base 49 of both sides. So if I had space, I would write it like this on the left and this on the right. And these cancel, leaving you with the 1/2 equals the log base 49 of 7. Log base 5, because 5 is the base of the exponent, giving us 3 equals log base 5 of 120. 13 is the base. Take the log base 13 of both sides. Getting us 2 equals log base 13 of 169. Okay, this is the logarithmic form of 13 squared equals 169. Log base 4 of both sides. I'm writing it out now in this extra step, though. You know, you can do what I was doing before as long as you understand that you're writing it like this, not as like a base of an exponent or something like that, not as something crazy, just like this is your first step. These cancel, leaves you with a -3. -3 equals log base 4 of 1/64. Log base 10, this is where we can just use log, assuming that log has the 10 as the base. Log base 10 of 10 to the -3rd is -3. So -3 equals log 0.001. This is something you can easily type into your calculator. There's a log button on your calculator. Here's your calculator. There's a log button right here. You can type in log 0.001 and you'd get -3. And we'll teach you how to do logs of different bases using your calculator. There are multiple ways to do that, but there you go. 81 to the 1/4, I take the log base 81 on both sides. Log base 81 of 81 cancels, leaves you the power 1/4 equals the log base 81 of 3. 9 is the base, so I'll take the log base 9 of both sides. Log base 9 of 9 to the 3/2 is just 3/2. These undo each other, and then here I have log base 9 of 27. So for these, there's multiple ways to do it. Once we do this kind of like my way a couple times, we'll be able to do things maybe quicker. A lot of people see this and they're like, I don't know what to do, or like, can I type this into my calculator? We don't want to type this into our calculator. We should be able to evaluate this without a calculator, all of these. You can maybe use a calculator to check once we learn how to use our calculator to evaluate this. I'll probably teach this on day 2 for my students. But what I do is treat this as like as an equation, or it's like, I don't know what this is equal to. So log base 4 of 16 is some number. Well, I'm going to rewrite this in a form that most students are more familiar with, which is in an exponent form. So I'm going to get rid of the log base 4 by doing 4 to the power. This is how we undo a logarithm, is the base to the power of both sides. So I'm going to rewrite this as 16 equals 4 to some power. What is the power? 4 to what power is 16? It's 2. So my answer here is that log base 4 of 16 is 2. Now, once you figure this out, and let's do the next one. You know, this is some number. Okay, how do I figure out that number? Maybe rewrite it as an exponent form. Take 3, which is our base to the power of both sides. I get 81 equals 3 to one number. What is that? 3, 9, 27, 81. So 3 to the 4th. So x is 4. Once we kind of figure out using these first 2 examples, let me just keep that here. We realize you see a log, it's like 3 to what power gives us 81? Okay, what? 4 squared is 16. So that's 2. 3 to the 4th is 81. That's 10 2, like 10 squared is 100. It must be 10 cubed. 10 cubed is 1,000. This would be 3. Okay, so this is how like we can use this fact, 1,000 equals 10 to what number? This number is 3. Yeah. ln, this is the first time that we've seen ln. This is called the natural log. The natural log is a log base e. E to a power is a commonly used exponent function. When we talk about compounding interest, e pops up a lot. When we talk about infinities and stuff like that, we use it a lot in calculus as well. So they have a shortcut since it's used so often. Just like 10 to a power is used so often, e to a power is used a lot. So the shortcut, instead of writing log base e every single time, is to write ln, or natural log. So if this is log base e of e to the 7th, well, immediately you can see, oh, this is like the same base here and here. This would undo each other. This just gives you 7. Another way to do this is like if you have log base e of e to the 7th equals x, you take e to the power of both sides, and it's like, okay, e to the log base e, this cancels, leaves you with e to the 7th equals e to the x. So obviously x has to be 7. So you will see the natural log fairly frequently in this class and moving forward into calculus. Log base 3 of 1, 3 to what power is 1? 3 to the 0, anything to the 0 power is 1. Rewriting this, 3 to the power, 3 to the power, you get 1 equals 3 to the x. X is 0. 5 to what power equals 1/5? Well, that's a -1. This is something that you need to know, like a number to a negative power is equal to 1 over the number to the positive power. I know you guys hate when we use like letters, so I'll just use a specific example, like 5 to the -3rd is not -5 cubed, it's 1 over 5 cubed. Rewriting this in exponent form would be 1/5 equals 5 to what power? That power is -1. 4 to what power is 4? It's 1. Here, if you take 4 to the power of both sides, you get this leftover 4 equals 4 to what power? 1. Log, that's again a 10. Log base 10 of 10, that's just 1. Okay, that undoes each other, like the exponent here, you can write it as like 1. You can write this exponent here as 1. So log base 4 of 4 to the first is 1. If you have anything like log base 27 of 27 to the third, log base 27 of 27 cancels, leaves you with that 3. That 3 comes down. So if you have any situation where you have the same base here and here, it's just going to be your exponent, whatever that power is. This is not that situation. This is log base 36 of 6. So you can either kind of take 36 to the power of both sides if you have an x here. If you take 36 to the power of both sides, you have 6 equals 36 to what power? That's going to be a 1/2 power, a square root. The square root of 36 is 6. So that's your answer. (27) to what power is 3? Okay, well, so you can't take the square root of 27, but you can take the cubed root of 27. The cubed root, so like the cube root of 27, we know that's 3. We got to know that a cube root is the same as a fractional power, a 1/3 power. So make sure we understand that and know that. That's where the kind of notation comes from. It's this fractional power. So that's 1/3. This is 3 equals 27 to the 1/3, or 3 equals the cube root of 27. This is a good one. This ends up being 64 to what power is 1 over 16? So this is a fraction. So we got to think about things like if you take the square root of 64, it's 8. Okay. You take the cube root of 64, it's 2. This is going to end up being like a negative power. I actually don't know what this is. What can I think? Wow, this is a tough one. This is a tricky one. Cube root of 64 is, let's think about that. What's the cube root of 64? Is it 4? 4 and 16 and 34, so 4 cubed is 64. Okay, good. So I know 4 squared is 8. Sorry, 4 squared is 16. So it seems like, and there's other ways to do this, like you could try to rewrite this, and this is what most people do, to be a version of 64. So you can start by saying, okay, 64 is, okay, instead of 1/16, I could write this as 16 to the negative first. Okay, but then like, how can I rewrite that to make it into 64? Gosh, I'm not even good at this. This ends up being negative 2/3. What is the easiest way to show you that that's negative 2/3? It's got to be a negative power. And then I need to cube root this to get 4, and then I need to square 4 to get 8. So that's how you kind of get the 2/3 here. How can I show that? Okay, ready? I think I got it. 16 I can write as 4 squared. So I'm going to write 16 as 4 squared. So I have 4 squared to the negative first. So 1 over 16, I can write as 16 to the negative first. If I have 16 to the negative first, I can rewrite this as 4 squared to the negative first. And then what I can do is to turn this 4 into a 64. I could say 4 is the cubed root of 64. So I could say, okay, well, 4 squared, I can write 4 as the cubed root of 64. So that's 64 to the 1/3. That's 4. Then I have the square. Then I have the negative first. And then all of a sudden, since I rewrote this 1/16 as a version of 64, the log base 64 of 64 will cancel, and it gives you the 1/3 squared to the negative first, and that gives you that log base 64 of 64 to the negative 2/3. I could have gone back and done all these problems like that, and I think a lot of people teach that way, where it's like not easy to do. Like, let's go back to 25 and 26 and 27. So I apologize if teachers teach the other way first. You can rewrite 16 as a version of 4. So I can say, okay, just write this as 4 squared. Log base 4, 4 squared. Log base 4, 4 cancels. You just left with the 2. 81 is 3 cubed. Log base 3 of 3 cubed. That's, these 3's cancel, leaves you with this 3. What's another one that's easy to kind of do that way? Maybe this one here. How could I turn 6 into 36? Well, 36 square rooted is 6. So I rewrite 6 as the square root of 36 so that I have the same bases, and then there's my answer 1/2. That's another way to do these. Probably for the more trickier ones, we'll do it that way. It actually isn't, this kind of rewriting method isn't that important when we get to calculus. It's more the solving and the rewriting that is important. Taking 5 to a power when you have a log base 5, or taking log base 5 if you have 5 to a power. Like, let's see what we do here. I'll show you like the other way to do this is to change this into something with a 5. Well, like 25 is 5 squared. So I could write this as the cube root. The cube root stays. That's a 1/3 power. So here's the 1/3 power. But writing 25 as 5 squared. You can combine these powers to say, oh, I got log base 5 of 5 to the 2/3. Log base 5 of 5, cancel each other out. The answer is 2/3. There's another 2/3. These are the trickier ones of the two, especially this one. How to write 1/16 as a 64. But that's an alternative approach to doing this instead of kind of rewriting and just kind of figuring out the number. We will again show you how you can get this answer. Like when I didn't know how to do this, I used my calculator and then showed you how to do it. There are ways in the math button, there's a log base, and you can literally type in what you see. This is in math. I'm going to teach you this tomorrow, next class. And then there's also this thing called the change of basis formula, where you can do the log of any base. So like log base 10, you press the log button of the top divided by the log of the bottom. Again, we would teach you this on the next class. But this is what we kind of need to build towards solving equations for x, where it's in an exponent form or in a logarithmic form. So this is where kind of my rewriting method, where you're doing the inverse, helps. You pay attention to the base. Natural log, again, is log base e. Or you pay attention to the base of the exponent. So I'll show you like both of them to show you like, okay, if it's this situation, you do this. If it's this situation, you do this. Log base 3 of x equals 2. You would take 3 to the power of both sides. This is the inverse of a logarithm. It's an exponent. The inverse of an exponent is a logarithm. 3 to the log base 3 of x is just the x. The x is going to be left. 3 to the log base 3 cancels. So I get x equals 3 squared. So x is 9. Log base 3 of 9. Okay? So that's if you have a logarithm. I'm doing that. If you have a number to a power, like let's look at this one. You would take the log base of that base number of the exponent. So log base 3 of both sides. Log base 3 of 3 to the x is just x, and then on the right side I have the log base 3 of 7. We don't know what this number is. This number is going to be a fraction, like 3 to what power 7? I know it's something less than 2, but greater than 1, because 3 squared is 9. 3 to the first is 3. We'd be able to figure out that using a calculator, which I'm not going to stress right now, but next class we'll talk about typing it in. It's 1.771 with a bunch of decimals after that. Same thing here. I would take the log base e of both sides. The log base e is the same as the natural log. So log base e of e to the x is just x. This is the natural log of 10. You can type in the natural log of 10 into your calculator using the natural log button. The ln button, natural log button is right here. Natural log of 10 is 2.302 with some decimals after that. Okay. So those are examples of both. Let's just finish off the top, then we'll finish off the bottom. So here, log of base x of 81 is 2. I would take x to the power to give me 81 equals x squared. Here I can square root both sides to get x equals positive 9 or negative 9. Can we take a negative base? Yeah, I think we can. Like negative 3. Yeah, I think we need the plus or minus. Yeah. So log, I'm just going to double check real quick. Actually, log base negative 1. Yeah. So we'll talk about how you can't take the log of a negative number, like a log of negative 3. If you type this into your calculator, it says no dice. Because if you think about it, you take 10 to the power both sides. There are no numbers that you could plug in for x, so that 10 to a power is a negative number. Like even if you plug in negative 4, that becomes 1 over 10 to the 4th. That's going to be a very, very small number, but it won't be a negative number. So it's not super important for like all of our questions. There's never going to be a question similar to this that I've seen where you have to worry about the plus or minus kind of thing, but just telling you, you just need the positives done. Okay, log base 25 of x equals 3 halves. What I do here, I would take 25 to the power of both sides, 25 to the power of both sides. This undoes each other, gives us x equals 25 to the 3 halves. You need to be able to do this without a calculator. Moving forward into calculus world. I'd split this into 2 powers. You can either do 25 cubed to the 1 half. It's probably easier to do 25 to the 1 half cubed. 1 half times 3 is 3 halves, so this is fine. Power to a power, you multiply these powers, you get 3 halves. But this is easy because 25 to the 1 half, the square root of 25, that's 5, and 5 cubed is 125. Yep. Oh, I had a long break too, so my mental math is much wrong. E to the power undoes the log base e. So here I get x equals e squared. You don't have to worry about like simplifying e squared to figure out what that is. Last two, the answers are decimals, obviously. 10 to what power is 12? Well, it's something a little bit bigger than 1. You would take the log base. I've had in the past, let me look at this going, a white pen, and watch what I can do with this white pen. I can kind of like erase that. That would be better. Log base 10, log base 10. Get x equals log base 10 of 12. We'll be able to type this into your calculator to get a decimal approximation. Math, log base 10 of 12. 1.079. Got that. Last one, e to the x is pi. Take the natural log of both sides. This is a log base e. Log base e is the same as the natural log, so ln both sides. You get x equals ln of pi. You can type that into your calculator easily. Ln of pi is 1.144 or 1.145. All right, hopefully this is a good understanding of things. If you use this method of like just immediately saying like logs undo a number to a number to a power undo logs, that will help you when we move forward and we start solving equations. We're going to get into some tough equations, and we got to learn how these logarithms, they have properties, and the properties of these logarithms are like exponent properties, and we would use kind of those properties to help solve different equations, and we'll get into some tough stuff moving forward. But first homework video, hope you enjoyed, hope it didn't confuse you, and we'll see more of you moving forward.